Typically, when you convert a passenger aircraft into a cargo or special mission or any military applications, you take the acrylic window, typically a maintenance hassle, and you replace that with a metallic machined window plug. So for an aircraft, every pound counts, right? So with each window plug, giving you a 20% weight saving, and when you have 150 plus window plugs, that's a significant weight saving for an airplane that give you higher fuel efficiency as well as a longer range. If you want to produce a complex part, typically in a metal world, we start with a billet and we machine about 60 to 80% of that billet to produce a complex part like what I'm holding here. What we're trying to do is we're trying to combine two technologies that are matured in aerospace. One is the thermoforming along with the injection molding. So when you combine those two technologies, we refer to that as injection overmolding. You're injecting thermoplastic material over the continuous fiber so you can fuse these two materials together to form a complex structure. So it's lighter and faster. And also, if you look at the production cost, it's actually cheaper than the metallic process.
So we started in Germany back in 2012. We started with the development of this technology mainly for the automotive industry, but also used for some sporting goods, sports industry. And I'm really happy to see this technology transforming to the aerospace. Yeah. I got in touch with Nair and Atlas in 2022. So it was the K show in Germany, Düsseldorf. And I met with my now supervisor in Kraus Maffei, and he offered me the possibility to move to USA and to support Nair and also Kraus Maffei with research development and making new customers, business fields in the aerospace industry. It's a really nice partnership from my point of view. I'm also enjoying it a lot to work with Varuna, but also with all the students here to teach them something, and also they are hungry for the technology and to learn something, so I'm really enjoying it.
If this was, most other labs, you'd be looking at a machine that's maybe 10, 20 years old. This cross-on-fire machine, this is pretty much state-of-the-art. This is what every other automotive company, they are using these machines to make their parts. At this point, their field of research for these machines have been very mature. So what we are trying to do is, use that technology and then apply that into aerospace as well. When you're running a machine like this, you do need an expert that has operated this machine for a long time. Eugen comes with 17 years of experience. He's the perfect guy to teach us how to use this machine to make parts like this. He
already seen so many parts made before and throughout his career. For him to give the insight or the heads up of what caveat gonna happen while we're trying to do this process, it's very valuable.
So the WindowPlug is the first project ever for the aerospace, which also gets certified and will go on a flying airplane soon, right? But I'm also looking forward for other projects and possibilities, especially for the eVTOL market.
These companies want to build these in thousands of aircraft a year. If you look at the market projections, the investment's going to be 3 times in about 5 to 6 years than what they are investing today. I mean, you're talking about $35+ billion. When you produce these composite structures, thousands of them, you cannot use the traditional ways of producing composite parts. It takes time. So obviously we demonstrated that we can produce this aircraft window that is comparable to the metallic aircraft. You put something on an aircraft, you got to go through a certification procedure, which is an important aspect of introducing something new to an aircraft. But if you have a structure similar to this, you can literally use a carbon copy of that process, not just to produce it, but to design, manufacture, analyze, and certify any structure.
For further information about this groundbreaking technology and our other innovations, get in touch with us today at the Office of Technology Transfer and Commercialization.